All right, this is lesson 3, day 1, and today's lesson is about finding characteristics of functions, and mainly it's going to focus on domain versus range in this lesson. Starting off with a warm-up, we're determining is this a function or not. If you remember, and you watched the last video, you noticed that it said anytime each domain has exactly one range, and remember domains are x's and ranges are y's. If each of these only has one answer over here, then it is a function. 2 only has one answer, 5 only has one answer, 6.5 only has one answer, 9.75 only has one answer. So, ladies and gentlemen, this is a function. And the reason why it's a function is because each domain has exactly one range. That's what I would write there. So the answer was yes. Yes, it is a function. Maybe I'll just write that instead of function. So is it a function or not? Yes, it is. And the reason why it is a function is because each domain has exactly one range. All right, is this one a function? That is new. And the reason why it's not a function is because of this. The domain of 3 has 3 different ranges, has 3 different heights. So domain is x. So if you think going across to x to any number, if you go up, you should only have one answer. Now, you might have learned maybe last year that it's called the vertical line test. It doesn't pass the vertical line test here because the number 3 has 3 different ranges. Or you could have also said that the number 4 has 2 different ranges, and therefore that's also a reason why this is not a function. All right, number 3. 12, 8, 16, 8, 24, 7, 32, 7, 64, 6. This is a function. And some people might think it's not a function because, oh, look here, we got 2 7s and we got 2 8s. That doesn't matter. It only matters that each domain has exactly one range. It doesn't matter if the same range has 2 different domains. That is irrelevant. All right, done with the warm-up. So once again, I told you that today's lesson, and it starts off with an activity that gets you thinking about what a graph would look like, what is domain, what is range, what does it look like when you're looking at a graph. That's what's important. That's what we're trying to get here. All right, so here's a graph of throwing the ball up into the air, hits its highest mark, and that's the highest height in feet, and this is time in seconds. After 6 seconds, it hits the ground. Write a function for the statement of the situation. So that would mean that the dependent, which is the height of the ball, is a function of the time it's been in the air. Okay, pen's not working out so great. I might have to reset it before the next video. So I'm just going to have to listen to what I'm saying here. So what is the domain of the situation? The domain, I am going to write this part though. The domain is very important. It's 0 to 6. X can be anything between 0 and 6 because 0 is when the ball was thrown into the air and 6 is when it hit the ground. So if you want to find an answer, anything in between 0 and 6 is going to have a height. What is the independent and dependent variables of the situation? The dependent is the height, independent is the time. What is the range of the situation? The range is 0 is less than or equal to y, because we're talking about height, which is less than or equal to 60. 0 is the lowest the ball was. 60 is the highest the ball was. Now you might be thinking, well, wait a second. This isn't a function because it has a height of 30 twice. It does not matter if a range happens twice. Remember what I said about a function? Now you can see that it makes sense. The ball can't have 2 different heights at the same time because that would be silly. That's the reason why this is a function. Can't have 2 heights at the same time. You can be at the same height at 2 different times. Now you see it. It makes perfect sense. Are the variables discrete or continuous? This is continuous because the ball always has a height. The independent variable, which is time, will always have an answer. Always. Even if it's a half. In this relationship, can a domain value have more than one range paired with? I think I've already answered that. I think the fact that a range can have more than one domain, but a domain can have more than one range. So this is a function. All right, so now we got another one. I think I might have even deleted this one from your lesson, but it's the same kind of thing. It's a graph. It's got a domain of 20 through 50 because that's where the graph is. It starts at 20 and it ends at 50. If we're talking about range, It has a lowest point of 2 and a highest point of 5. So domain, you're asking yourself, how far left and right does the graph go? And range, you're asking yourself, how high does the graph go? Okay, so that's basically all that is. I'm going to keep practicing domain and range because that's what I want you to get out of it. Oh, it might not be a graph. Maybe it's going to be a table. Well, the domain in this case is going to be a list of all the possible numbers. Now, I'm using brackets because that's how I like to keep my numbers nice, neat, and organized. 32 and 40. All right, so there's my brackets. What is the range? That would be 31. You don't have to put them in order. If you do, that's great. 18, 16, and 11. Now you might be wondering, why didn't I write that 18? Because it repeated. The point of a range is a list of all the possible answers, not a list of all the answers as they're given. So you don't want to repeat things because we already know it's a possible answer. If you write it twice, then what's the point of that? This one is a discrete question because you can't buy a ketchup bottle anything in between. If you try to cut the glass ketchup bottle in the middle of the grocery store, they're going to charge you full price for the bigger one and probably make you clean up the mess. There's nothing in between. You can buy a 6-ounce jar, a 12-ounce jar. You cannot buy anything in between. All right, so this is part of the homework. I believe this is the bottom portion of your homework. So we'll do this, and we'll talk about the other portion of the homework in the other video. All right, 0.68 is on a graph. So the function notation of that would be, ooh, this is a tough one. F of 6 is 8. The independent variable is always the x. The dependent variable is always the y. So if it's f of -9 equals -2, -9, comma, -2. Oh, this is such an easy homework. I love easy homeworks. All right, so the next one, -6 blank equals f of blank equals blank. All right, so then what you'd have to do is you'd have to go to the graph. Yeah, I'm holding your packet up right here. Look to find where is -6. 1, 2, 3, 4, 5, 6. Sorry, I can't show you where I'm pointing at. It's right there. And -6 is at 0. So -6, 0. F of -6 is 0. All right, so the last question is asking us, when is the answer 6? So basically, when does this graph have a height of 6? So I'm going to look for 1, 2, 3, 4, 5, 6. There it is. 1, 2. It looks like it's 3 seconds after 0. So it looks like it's 3, 6. Now, I'm not 100% sure. Let me double check that. 1, 2, 3, 1, 2, 3, 4, 5, 6. Yes. All right. So nobody's going to be questioning my video because it is 100% correct. All right. Thanks again for watching and have a great